Thank you, Wendy, and thank you, all of you, for taking the next hour to learn about a subject that I'm personally very passionate about. I'm excited to share, and I'm really looking forward to our time together. Before we jump in, before we talk about anything, I'm going to make you guys all three promises. I make these same three promises at every webinar and educational event that I do. Promise number one, I am going to be as engaging as I possibly can be, given the medium. All right, this is a webinar. I attend webinars too. It's hard to pay attention during webinars. You have people knocking on your door. They just need 1 second. You got, emails popping in, Teams calls coming in. However, I believe that this is life-saving information, that if we integrate this information, these policies properly, that we will successfully separate people from hazards, prevent people from being injured or dying from a fall. So I want to share this information in a way that I can get you to pay attention to it. So that way you can implement it properly. So that's promise number one. Promise number two is I am going to be very practical. I'm a field guy. I'm not going to be debating nuances in the code. We're going to talk about how to apply these codes, how to apply these principles out of my time on roofs. So I'm going to tie everything back to be as practical as possible so you can walk away with, I need to do something. Here's what I'm going to go and do with this knowledge. And promise number three is that this is not a sales pitch. I am here to educate you. My goal is to give you the knowledge that you need to help separate your employees from hazards, specifically falls from height. If you work with us to protect those employees, that's great. But if you just take this knowledge and apply it, I take that as the win overall. So those are my three promises. But what are our real learning objectives? What are we actually going to talk about? Well, I noticed, I've climbed down a lot of roofs. I've been doing this for slightly over a decade. I'm not going to say how much over a decade I've been doing this, but slightly over a decade. And I noticed early on that it really didn't matter the type of roof that I was on. I kept seeing the same three hazards over and over and over again. If I was walking on the roof of a hospital or manufacturing plant or distribution center, I kept seeing the same thing. I kept saying the same thing and answering the same questions. So we put together this presentation to address the top three most common rooftop hazards that I've seen, and then it will exist on all of your facilities. We'll touch briefly on how to protect those hazards. So we'll address the hazard. We'll look at what OSHA says about it. We'll answer frequently asked questions. And then we'll talk about how to protect each hazard using some of our solutions. And then the meta, kind of the overarching theme that I want everybody to pay attention to is the order in which I present these hazards. So I want you guys, as you walk away from this webinar, my goal is for you guys to all say, well, if I could do one thing to make my roof safer, what would it be? I want you guys to be able to answer that question specifically. So before we dive into the nitty gritty, we'll dive into the OSHA code. I want to set the stage. I want you guys to visualize, okay? So let's just pretend. Let's pretend you called me out to take a look at your roof. So you said, hey, Dan, we've got some issues. We want you to come out and address it. Why don't you come down, sit down, have a conversation with us? So we're sitting in a conference room. We haven't been on the roof yet, and you're explaining what your concerns are to me. And what you would most likely say is, hey, Dan, we've got some units near the roof edge. We really need you to protect them. And I would say, absolutely, we'll take a look. We need to protect those areas of your roof. But before we get there, the first hazard that I want to talk about on your roof is the access point. That's the first area that we need to address when it comes to fall protection. I'll get to why that is in a second. But first, let's just break down the code itself. So where we pull this code, I'll give you guys a 20-second crash course in OSHA. So OSHA stands for the Occupational Safety and Health Act, or Occupational Safety Health Administration is the enforcement branch. OSHA has basically two books. You have a general industry book and you have a construction book. The hazards that you come across in general industry, which is the maintenance of the facility itself during its lifespan, are totally different than the hazards that you're going to come across during construction, right? I don't see, we are in a facility here in Buffalo, New York. We don't do a lot of overhand bricklaying as a day-to-day part of our operations, right? And when you're doing overhand bricklaying, you're not really worried about ergonomics and lighting. So there's just two totally different books. We're referencing 1910.28. The 0.28 means that we're talking about the fall protection chapter in general industry. So you want to Google it. I tell everybody, Google these codes and read them for yourself at OSHA.gov. Now, you may be watching and listening and say, oh, no, I think you're wrong. I think that the OSHA code is 1910.23. And you wouldn't be wrong. That was what the OSHA code used to be. Back in 1977 to 2016, it was 1910.23. Then they updated the code, and now it's 1910.28. They didn't retire the jersey number, which really is confusing. So you can still look up 1910.23, which is now the ladder's requirement. So that's your 20-second non-accredited crash course in OSHA and understanding the codes. But let's break down this portion. So this is 1910.28, subpart B34. So now we know what sentence to look up in that code. It states that each employee must be protected from falling into a ladderway floor hole or a ladderway platform hole with guardrail erected on all exposed sides except to the entrance to the hole where a self-closing gate or an offset must be used. So there's a few new terms in here, right? There's the term ladderway floor hole and ladderway platform hole. Now, I always like to remind people, OSHA, it's the law. It's written for lawyers, by lawyers. So they use terms that we don't really use that much, right? I've never walked on a facility and heard somebody say, hey, why don't you climb up through the ladderway floor hole and I'll meet you on the roof, right? Or nobody says, hey, why don't we climb this ladderway platform hole and climb up onto the roof, right? What do we say? Say, climb up the roof hatch, I'll meet you up there, right? The ladderway platform hole, the roof is our walking working surface. So our roof is the floor. And the ladder is coming up through a hole in the floor. So that is what we would call a roof hatch. A ladderway platform hole, the roof is a platform that I'm stepping onto and off of. It's my work platform. The fixed ladder on the side of the building is my ladderway platform. And the hole is where I'm climbing up and through the openings in the ladder to make access. So it's saying if I've got a hatch or if I have a fixed ladder, I need to protect it. I need to protect it by using guardrails and a self-closing gate or an offset. Offset, simple to understand. Picture your guardrail as like a turnstile at a bank. So I can walk up to the guardrail, I turn right, I turn left, I get onto the roof. We'll also like to design these as like a cattle chute to the middle of the roof. So you have guardrails that bring you to the center of the roof. So that way I can engineer my footpaths from the middle out. So we don't have people walking along the edge and end up in a precarious situation. So those would be examples of an offset. The term self-closing gate is actually a very important nuance that I'll address in our frequently asked questions section coming up. But first, I have to tell you why. You called me, we're sitting in your conference room, and you want me to take a look at your leading edge. And I'm saying, yeah, but we got to talk about your hatches first. Well, why am I saying that? How do I justify that stance? Well, to understand that, we first have to understand how do you assess risk in the first place? We all assume risks every single day, but we assume them to be an acceptable level of risk that we're willing to take. If you drove your car to work today, you accepted a risk of getting into a car accident, but you put controls in place to reduce the likelihood of an accident occurring and the severity of the accident should it occur, right? Like you drove according to the speed limit. You obeyed all traffic signals. That reduces the likelihood of an accident occurring. You put on a seatbelt. You have airbags. That reduces the severity of an event should an accident occur. So we look at risk in basically two metrics: the severity and the likelihood. The tool that's used by the industry is called a risk assessment matrix. So in this, we rate the severity of an accident should it occur from 1 to 5. So 1 means that it would be an insignificant injury, no lost time, treatable by basic first aid. 5 being a debilitating injury or potentially a fatal injury. So that's the scale. Then likelihood, we rate from 1 to 5, nearly impossible being the 1, and almost certain being the 5. We take our ratings, we multiply them together, and it gives us a risk rating. Anything 15 or higher is a critical risk, needs to be taken care of right away. Anything 6 to 12 is a moderate risk, and anything 1 to 5 is a neutral risk that we would say, yeah, I'd take that risk. I would assume that risk. So let's take this principle now, the idea of a risk assessment, and let's apply it to rooftop fall protection. Potential severity is really easy for us to predict in a rooftop fall protection scenario because we're always at a 5. No matter what the height, we always have the potential for a debilitating injury. And the way that I explain this to people, I say, okay, don't really do it. Well, let's just pretend you're sitting at a desk that's about 4 feet high. 4 feet is the minimum height requirement at which fall protection is required in general industry. If you say, no, that's not right, it's 6 feet. Everybody knows it's 6 feet. 6 feet in construction, 4 feet in general industry. And let's just say you're 6 feet tall. So you stand on your desk. Your head is 10 feet above the ground and you just mummy fall backwards and you hit your head on a concrete floor. Are we talking about a potential debilitating injury? Absolutely, we are. You fall at 32 feet per second squared. So if you're working at 90 feet above the ground, that fall is going to happen in less than 3 seconds. And the amount of force that's generated during a fall is actually insane. So it doesn't matter the height that we're working at. If we're above 4 feet, we have to assume we're working with a 5. The term likelihood gets kind of wishy-washy. You know, it's kind of a subjective term. I like to kind of listen to how people talk in facilities because what I do is I hear them when we're debating where we should protect, what areas we should protect, and they start to kind of debate back and forth the likelihood of a fall occurring, but they use super subjective terms to rate likelihood, right? One of the most popular ones is, well, we've never had a fall. You know, nobody's fallen, and they always go, knock on wood, you know, so we're probably okay. And it's like, yeah, if knock on wood's in our safety plan, it's not a good safety plan. I've had people tell me, you know, I'm not scared of heights, so I'm not going to fall. I'm real sure-footed up there. And I'm like, yeah, man, that's not how gravity works. Like, you know, like you're not wearing like gravity boots. Like you're not going to not fall. I was in Texas, this is a true story. I had somebody tell me I could totally land this one. I'm like, no, man, you can't. Like, we're like 30 feet up. You're not going to land this one. You're not a cat. You're not going to just parkour jump. There's a big difference between a jump and a fall. So I actually don't like the term likelihood when we're talking about risk and rating risk. It's too subjective. So I like to turn it into something that's actually a measurable, an objective measure. So let's take the word likelihood and let's change it to frequency of exposure to the hazard. The higher exposure count I have to a hazard, the more likely I am of an accident occurring, right? Good example of this is swimming. Statistically speaking, you are more likely to drown in a swimming pool than in the ocean because we just spend more time swimming in pools. Pools aren't inherently more dangerous than the ocean, but the frequency of exposure at pools is way higher. It's an interesting statistic is that you are more likely to get into an accident within 2 miles of your home than anywhere else. Well, guess what? Every time you leave and go home, you're within 2 miles of your home, right? The volume of your driving is within 2 miles of your home. So the frequency of exposure is what impacts, is an objective measure that we can look at when assessing risks on a roof, helping us prioritize hazards. So let's take this idea and let's apply it to a roof. So let's just do an example. And let's say in this example, our primary access point will be this hatch right here. So we're just going to pretend this ladder doesn't exist. And on separate occasions, we can't stack trips. On separate occasions, I've got to service this unit twice a year. I got some belts in there that need to be replaced every once in a while. I've got a motor with PMs. I'm up there at least twice a year. Once a year, I've got to reseal these skylights because skylights leak. That's just what they do. So we're just resealing them every year. 4 times a year, I'm at this HVAC unit. We've got filters that need replacing. We've got equipment. We've got belts, and we've got PMs. So at least there 4 times a year. And then we've got drains along this edge. And, twice a year, spring and fall, we're up there cleaning out the drains. So the question is, which hazard on this roof has the highest exposure count? So I'll give you guys a minute. So looking at it, a lot of times in classes, I get people say the edge, right? Because I'm here 4 times. I'm at this edge 4 times. I'm at this edge 6. So really, or 2. So really, this corner has a 6x exposure count, right? So that's got to be the priority. That's where we're there the most often. The answer is no, because every time I come on the roof, I've got to come through my access point. So I'm going to hit my access point. 2 plus 1 is 3, plus 4 is 7, plus 2 more is 9. 9 times, right? Wrong. 18 times, because I also have to come back down through the access point. So my exposure count is exponentially much higher at my primary access point than anywhere else on that roof. So by hazard count alone, we say we've got to protect your access points. And it's a quick, easy win. First thing to kind of, start your journey in fall protection, get your facility up to compliance. Another reason I always like to say prioritize your access points, because I fall into the same trap when I do roof walks, and I've been doing them forever. What do you do at an access point? 3 of us are going on the roof. I climb up, I unlock the roof hatch, and I stand up there. I stand next to the hole. I wait for you to climb up. You stand next to me. Wait for the 3rd guy. We're all milling around this opening, waiting for everybody to get together. Then we say, all right, what are we going to go and do? And then we go and do it, right? So it's like a little milling point. And then what do we do on the way down? I go, you climb down the hole. I stand at the hole looking down to see if you're up the ladder. An exposed opening as a fall protection expert standing right next to it. And then I climb down and then you do the same thing. So it acts as a kind of a natural gathering point or a collection point for people on the roof. Again, as an expert, I make that mistake all the time. I have to be very conscious. I get up on the roof. I walk 10 feet away from the opening. I stand there. I wait. You follow me. And we talk about protecting that access point. Now, when it comes to understanding hazards, there's 2 factors, right? Time and exposure. So leading edge is still a critical area that needs to be protected, and we'll address it. But from an exposure count only, exponentially, we're going to prioritize access points. Frequently asked questions. Number 1 question that I get when it comes to access points is if I can use a chain instead of a self-closing gate. Where this question comes from is back, I read you guys the code from 1910.28. If you were to go back in time and you were to read that code pre the update, the 1910.23 version of that code, it would read almost identical to the original code, except for 1 term was changed. The gate got changed from being described as a swing gate to a self-closing gate. And then in like 1982, 1983, a letter of interpretation was sent to OSHA where somebody asked the question, can I use a chain instead of a swing gate? You got to close the gate behind you. You got to reattach the chain behind you. It's the same, right? And OSHA said, yeah, you're fine. Use a chain. So everybody started using chains. New code comes out. They call it a self-closing gate. And the question becomes, well, can I use a chain still? To answer that, where we pulled this text that's on the slide from, we have to dig into the Federal Register. So the Federal Register has the documentation of the justification for every change that OSHA made in the new code. And they address this directly. And they say, no, we don't consider chains to be an effective means of fall protection for 2 reasons. Reason number 1, nobody puts the chain back. So they just kind of dangle there doing nothing. But reason number 2, on the way down the ladder, you're hanging on the side of the building. You have to reach up above your head to reattach the chain while you're hanging off the side of the ladder trying to maintain 3 points of contact is a potentially very dangerous thing to be doing. So if your safety causes a hazard, it's not a good safety measure. So therefore, they're not considering chains as fall protection with no grandfather clause. So it's just starting immediately, immediately being, 6 years ago now, starting immediately, you need to get this addressed and fixed. The other question that I get about access points is all about the height of a ladder and the requirements for tie-offs, right? Everyone's confused. Nobody understands, can I use a cage? Can I not use a cage? When do I need a cage? So I'll just make it really easy. Cages, they're still allowed. They have not been outright banned by OSHA unless they're so tight that you can't climb in them, right? But cages are not considered fall protection. Cages never stopped anybody from falling, right? When you're climbing a ladder, how do you fall? You don't like throw yourself off the ladder and Spider-Man into the cage, right? That's not how it works. Your boot slips. Your boot slips and it slips while you're making your reach up here. So all of a sudden, all your weight is landing right here and you aren't strong enough to catch yourself and you fall straight down. So that's how a fall on a ladder occurs. What happens with the cage is you just kind of get mangled up in the cage as you fall. And it's really hard to rescue people when they're stuck in that cage. So that's why OSHA said, if you have a ladder 24 feet or higher, you need to have a fall climbing device on it. It can come in different forms. It can be a davit, an overhead anchor point with a tag line that you pull down, you tie off to your dorsal D-ring, you climb up. If you fall, it snags you, keeps you from hitting the ground. It can be a rope, vertical rope with a traveler on it tied to your chest that you climb up. That has a brake on it. If you fall, it locks off. It can be the same thing, but with a cable. It can be the same thing, but with a track that goes up and not down. It can be in all kinds of different things. But if it is a ladder over 24 feet, it needs to have that on it. If it's a newly installed ladder or a major retrofit on a ladder today, it needs to have it on it. And we have by the year 2036 to retrofit all ladders in the US with climbing devices if they're over 24 feet. And I heard somebody said it the other day. They were like, you might as well do it now because they're going to be really expensive in 2035. So do your retrofits now because come 2035, they're going to be off the shelves. Everyone's going to be sold out. Other companies are addressing this by basically banning ladders. A lot of companies are going to stair towers, not using ladders whatsoever because it's kind of a pain because then you have a full PPE management program around the harnesses and the devices that you need just to climb ladders at your facilities if everything else is safe, with guardrails and things like that. So a lot of companies are just going away from ladders completely if they can, where practical. As far as solutions are concerned, we provide a system called Key Hatch. We put guardrail around the opening of a hatch. We integrate a self-closing gate. I like systems where we'll actually design grab bars kind of as part of the system itself. So I have something to grab onto as I'm climbing out of that hatch to make egress a lot easier. There's nothing worse than climbing in and out of a hatch. I've done it hundreds of times. You got nothing to hold on to. You're laying on your belly. You're crawling out. Down south, you could fry an egg on the lip of that hatch because it's so hot. It's burning your arms. Up north, you're sticking to it because it's frozen. It's like the scene with the tongue stuck to the flagpole. It's just rough. So give yourself something to grab onto to make that egress easier. Fixed ladders. We put non-penetrating guardrail either along the edge or, again, shooting into the middle of the roof to design traffic, engineer your traffic away from the edge. And then we integrate the gate to the railing. A gate should never be mounted to a ladder. There's nothing worse than climbing a ladder at the top of the ladder. It's an awkward thing. It's hard to transition your body from climbing to walking. It's awkward to do that, and it's terrible when you got a ladder or a gate smacking you in the face the whole time. You're wrestling with this gate. Install your railing. It's on the inside of the ladder because it's sitting on the roof itself. we attach to the ladder, and then we put the gate, it's 8 to 12 inches on the inside of that area. So you transition your body, you step onto the roof, your body pushes the gate open, it closes behind you. You shouldn't even have to touch a gate with your hands. That's a properly designed access point. So there shouldn't be any pinching, any wrestling, or any awkward behavior at the top of a ladder. If you see it, fix it. Because I mean, it's so bad when you're at the top of a ladder and it's smacking you, and you're in a very precarious spot. Okay, so 1 of 3 down, everybody. We're good. I promise the next 2 will go faster than the first one. But that is the first hazard that I always like to talk about. So just take 20 seconds and think about your facility. How is it being accessed? Is it fixed ladders, roof hatches, stair tower, staircase, internal roof door? And where's the leading edge in relation to that opening? One of my biggest pet peeves is climbing a roof hatch. You're climbing up a wall, you open up the hatch and you look, and it's the edge. You just crawl up and out and over the edge. It's horrible. So really be on the lookout for that. As a double hazard. I could fall off the edge or inside the building. We need to protect both. That's like top priority if you have one of those scenarios. Okay, so we've covered our access points. You're like, all right, Dan, you talked us to death on the access points. Can we protect the leading edge, please? And I would say, absolutely, we have to do it. But first, we have to talk about holes in the roof, AKA skylights. The code that I'm going to reference here is 1910.28 subpart B31. It states that each employee is protected from falling through any hole. And in the code, in parentheses, it says including skylight. So OSHA is super clear. The skylight is a hole that's 4 feet or more above a lower level. There's our minimum height requirement in general industry, 4 feet above a lower level by one or more of the following. So it's interesting. OSHA gives us options on this one. In access points, we don't have any options. Guardrail, gate. That's the only thing you're allowed to use. Now we get to pick from 4. 2 are good, 2 are bad. And I'll explain what I mean by that. Option number 1 is a cover. Makes complete sense to me. You got a hole on the roof, cover the hole. A lot of times they'll use a screen as a hole so light can pass through, but a person can't. But you got a hole, cover the hole. Makes complete sense to me. Number 2 option, guardrail. Again, you got a hole, put a railing around the hole so people don't fall into the hole. Makes complete sense to me. Very simple. Then we get into a travel restraint or personal fall arrest system. So some of you may not be competent person trained according to OSHA, so you might not know the difference or even what a travel restraint or a personal fall arrest system is. So I'm going to give you a non-accredited 30-second crash course in the competent person OSHA fall protection class. In that class, you will learn about the ABCs of fall protection. A stands for anchor. It's what you're tied off to. B stands for body harness. It's what you're wearing. C stands for connector. The lanyard that connects your body harness to the anchor, right? That's your ABCs. Now, I can design my ABCs in 2 different ways. I can design a restraint system in which my connector is shorter than the distance between my anchor and the edge of the roof. So my anchor is 10 feet away. I'm wearing an 8-foot long lanyard. I can get to 2 feet away from the roof edge. I can get to the edge and not fall off the edge, right? I call it the dog leash. Right? Picture you're walking down the sidewalk. You hear a dog on the porch, doesn't like you very much. He starts running at you and he's barking. You hear the chain start to unwind as he's running at you. You're like, oh man, how short is that chain? Am I about to get attacked by this dog? And all of a sudden, boom, the chain goes 2 feet shorter than the sidewalk and you're safe, right? That's the idea, but you're the dog, right, in this scenario. That's a travel restraint system. Fall arrest, the key's in the name. You're going to fall, but we're going to arrest your fall. We're going to stop you before you hit the ground. Knock on wood, fingers crossed, you did your math right. So let's say in this scenario, I've got my anchor point is 6 feet away from the roof edge, and I'm wearing that same 8-foot lanyard. I get to the edge, 2 feet of my lanyard's going to go over, right? How much further do you think I'm going to fall in that situation? Well, I've got 2 foot of lanyard that's over. I've got the height of my body below the dorsal D ring. So there's 5 feet. So now I'm at 7 feet. I've got the harness stretch because that harness is going to end up stretching. So there's another foot. I've got the tear out of the lanyard itself, which is anywhere from 3 to 4 feet long. And I've got a safety factor. So I'm 12 to 15 feet down the side of that building without any, if I have a cable system with V deflection, which we won't get into. So minimum, I'm 12 feet down if I fall while being tied off. Now, why did I explain all of that? Well, let's pretend we're working on a roof with skylights on it. And I'm telling you, hey, you're fine. You're tied off. Don't worry about it. And you're like, all right, well, am I in a restraint system? So you're walking up to a skylight. Well, a skylight has 4 edges that I need to be restrained before I fall in. And I don't have just one skylight to worry about. I have like 40 skylights to worry about. And I got to work in between all of them. So I have like 160 edges that I need to worry about to stay in restraint around. It's impossible. So I'm going to be in arrest. Okay, don't worry. You're tied off. You'll be fine. What happens when I fall through a skylight? What's the first thing that's going to happen to me? I'm going to break the dome, right, with my arms, probably. So I'm going to get all messed up. I'm going to get all cut. But then what's going to happen? I'm going to fall through that skylight, and I'm going to fall at least 12 feet through the skylight. What's underneath there? I don't know. You don't know, right? None of us know what's underneath that skylight. So I might hit racking. I might hit electrical conduit or fire suppression line that's running underneath that skylight. I might hit an office. There might be an office right underneath me. I don't know what my fall distance is. What happens to the people below the skylight when I fall? So let's say I've got 12 feet arrest. It's fine. I'm just all cut up and bleeding and, hanging from the ceiling, but I'm fine. And overall, what happens to the people below me? Well, they're going to get hit by all the shards that I just broke. Plus, I'm going to be bleeding. So we have biological contaminants in that area. What if it's a food manufacturing plant or a clean room environment that's underneath me? Well, that's a batching issue, right? We got to clear that entire batch out, clean out the whole facility. That's a big, big problem. But we met OSHA, right? So it's important to consider OSHA as our bare minimum safety requirements. We can use fall restraint around skylights. I personally don't recommend it for all the reasons that I just explained. Frequently asked questions when it comes to skylights. Number one misinterpretation and misunderstanding around skylights is that skylights are fall rated. So this is a everybody for some reason tends to think the skylights are rated for a fall. The answer is maybe they were when they were manufactured, but probably not. The reason I can say that they're probably not fall protection rated is that most skylights are made out of plastic. Skylights are very simple to make. You get 2 pieces of plastic, you warm them up, you put like an argon gas, like a thermal barrier gas in there, you put air pressure in it, bubbles up the top, you let it harden, there's your skylight, right? You got a nice little bubble dome on it. Well, what happens to plastic in the sun over time? It's something called UV degradation. And the example that I like to use, which I've recently told dates me because people don't use this anymore. But when I was a kid, the white plastic lawn chair, everybody know what I'm talking about? Get those white plastic lawn chairs, you leave them outside for like 2, 3, 4 years, right? Picture you're at the family barbecue in the summer. You got a plate full of food. The only seat left is that like cloudy white plastic lawn chair. And you got to sit down in it. And you just feel it creaking as you lean back and the leg just shatter. Food's everywhere. That's UV degradation. That could hold you last summer. This summer it doesn't. Not because you ate too many hot dogs, because of the sun, right? It's the sun's fault. It makes you feel better. So it's the same idea, but with skylights are in the sun all day, every single day. They're getting more and more brittle. I've seen skylights I could put my hand through just from the sun eating away at them. The good news is that skylight manufacturers will put labels on them that say danger, risk of fall, because they don't want to get sued if somebody falls through their skylight. The bad news is those stickers are made out of plastic. So as you can see in the photo that I took, as the warning symbol is, burning off, it's becoming extremely brittle. So we don't assume that any skylights as a general rule are fall protection rated. And then last question, a little bit more rare, but every once in a while we'll see these things like a bar grid underneath the dome. And the question is, well, are those fall protection? The answer is, well, we have to understand what they're for. They're not designed for fall protection, right? Because they don't stop me from breaking the dome. And they may or may not be rated for 2 times intended load, which is what the OSHA loading requirement is for a skylight cover. Those are designed as burglar bars. So if you want to see one of these in action, go to Walmart, go to Home Depot, go to Costco, look up. You're going to see bars in the underneath of their skylights. It's so, a would-be cat burglar can't grab a ladder, climb up the building, smash the skylight, Mission Impossible, zip line down in, grab a couple of DeWalt drills, a few Milwaukees, rip them up through the skylights and disappear into the night. That's what they're there for. They're not there to keep people from falling. They're they're theft protection. So the reason why we don't consider those is because it doesn't eliminate all the hazards. So assuming even if it held you, if you're to fall, what happens to you when you hit and break the dome? You're still cut up. You're still majorly injured. What happens to people below the dome? We still have the struck by and the biological contaminants as well. Skylights, we get questions. We literally got a call, I think it was the fall of last year. There was a school called us up in the Northeast, and they said, hey, do you guys sell skylight protection? We said, yeah. What's up? So, well, we have students that broke onto the roof, and they were using the skylights like trampolines, because if you jump on the plastic, it goes convex, and then it pops up. It would launch them. And they were taking turns to see how far they could get launched until one fell through. And it was over the gym. It was a 30-foot fall. But by miracle, for some reason, they had folding tables out in the gym, and he landed on the folding tables enough to break his fall, and he didn't get a serious injury. So that's the crazy, think about the craziest things around skylights. And they were like, do you guys sound like, yeah, we'll overnight you them. That is a crazy scenario to have. So the way that we protect skylights, we put screens over them. We do a non-penetrating screen. We box out the curb using tension. We set the screen inside of this channel, and then we lock it down with the clips. And then that way we keep people from being able to break through that dome. Sometimes we can't do a cover because of the size or shape of the skylight, or because grid shadowing is an issue. So we end up using guardrails. We'll do a non-penetrating guardrail to box out the curb. So that way I can maintain my 200-pound load compliance at that top rail while still keeping people safe from falling through. So think about your facility. Again, do you have skylights? I'm a big fan. You can eliminate them. You can roof over them. You can't fall through a skylight that doesn't exist, obviously. But if you have them, I like the natural light. I like getting lead points. I like reducing the use of carbon, electricity inside the facility. I think it's great. But if you're going to do it safe, right? Let's have it be not a hazard on our roof. All right. We're 2 out of 3, ladies and gentlemen. We're doing great on time. If you have questions, throw them in the Q&A. We'll have time to kind of answer as many questions as I can at the end. But finally, we are at the leading edge. So to understand the leading edge, we look at 1910.38 subpart B13. And OSHA breaks down the leading edge into zones. So we have zones, 3 zones that we're going to look at, starting from the leading edge, starting from the edge of the roof and working our way into the middle of the roof. So we're going to talk about the first zone that we'll address is zone 1. So this is work being done from 0 to 6 feet into the roof edge. The term that I like to think of this is we are less than 1 body length away from the edge for any work being done in this area. A lot of times we talk about slips, trips, and falls as 3 different buckets of injuries, right? You have slips, trips, and falls. But a lot of time you can have a slip that turns into a trip that turns into a fall. It's a series of events. And in that series of events, we're actually going to move, right? Nobody actually does the mummy trust fall backwards, right? What do? You step backwards, you trip over a tool or something like that in your work area. You take 2 steps to try and catch your balance. You don't catch your balance, and then you fall, right? And if you took 2 steps, you traveled about 4 feet. And if you took 2 steps towards the edge and then you fall, your center of mass is over the edge. So any work, the most innocuous, basic accident in this zone can prove fatal. An untied shoelace, a stubbed toe, a twisted ankle, a bad step back, anytime we're working within 6 feet of the edge, you have a potential fatality from the most innocuous error that could happen, which is why OSHA has very strict requirements around any work being done in this area. So let's dig into the code. OSHA says that when work is performed less than 6 feet from the roof edge, the employer must ensure that each employee is protected from falling by use of guardrails, safety nets, restraint systems, or fall rest systems. So basically, OSHA is saying, if you're working in this area, you have to be safe. We don't care how you do it. You can even use a safety net. Catch them if they fall. But you got to do something. Now, I've never seen a safety net, in the real world, except for Top Golf, which if you just Google Top Golf safety net fall, it's a lot of entertaining content, seeing safety nets in practice. But in reality, OSHA is just saying, listen, I don't care what you're doing. If you're within 6 feet of the edge, you could be working there for 2 hours or 2 minutes. We don't care. You need to have some form of fall protection integrated. Simple, easy to understand. The next zone is where people tend to get a little bit confused. So the next zone is 6 to 15 feet from the edge. So we are 1 to 2.5 body lengths away. Now, what OSHA says is that when work is performed less than 6 feet, but more than 15 feet from the roof edge, the employer must ensure that each employee is protected from falling by use of a guardrail, safety net, travel restraint, or personal fall rest system. And then it goes on to say that the employer may use a designated area when performing work that is both infrequent and temporary. So we have 3 new words that we need to learn. What is a designated area? Well, according to OSHA, a designated area is a line, a warning line system, telling somebody that they're going to go into a dangerous area. According to the code, you can look it up in 1910.29, it is at least 39 inches tall with sag no less than 34 inches, visible from 20 feet, 200-pound tensile strength on the cable. That's it. That's the requirements. There's no tip over. There used to be a 16-pound tip over force. That actually isn't there anymore. It's just a visible demarcation that is physically present. But we can only use this at 6 to 15 feet if the work being completed is temporary and infrequent. So what does that mean? Well, to find that, we have to go into the Federal Register where OSHA discusses this. So according to OSHA, infrequent work is work that is sporadic or done as needed once a month or less, according to federal OSHA, once per quarter or less, according to Cal OSHA. So federal is a little bit less stringent, Cal OSHA is a little bit more stringent. That's typical. Temporary work is defined as work that takes less than 2 hours to complete in a single trip. So you go up, turn the machine off and on again, you pull the filter out, you bang it on the roof, jam it back in there. That's temporary work. You go up, you plug in your machine, you run a diagnostic. Oh, it needs new plugs. Okay, go down and get the plugs and the tools, come back up. That's not temporary work because it's 2 trips, right? So those are the nuances that OSHA, kind of is trying to explain here. Where I disagree with OSHA is the line at 6 feet, because there's really no difference if you're standing at 7 feet and you're standing at 6 feet and you fall backwards. If I have a demarcation line at 6 feet and I fall backwards, I'm still going to trip, slip, and fall off the roof edge. So our general rule if you see us in the field, is we're going to put warning lines no closer than 10 feet to the roof edge. If you say, now we want them at 6, we'll do it for you, but we'll always kind of give you the caveat. Safety best practice is at least 10 feet away from the roof edge. OSHA is seen, again, as bare minimum. Logically, I want at least enough room for me to take 2 steps, lose my balance, fall, and my center of mass is still in the middle on the roof with room for me not to fall off the edge. Then the third zone is 15 feet or more. So now, listen, we are 2+ body lengths away from the roof edge. So I need to slip, trip, fall, somersault, then get my center of mass over the edge. So I'm feeling pretty confident in this area personally, and OSHA wrote the code to match that. It states that when work is performed 15 feet from the roof edge, the employer must protect each employee from falling by use of guardrails, safety nets, travel restraint, fall arrest, or a designated area. The employer is not required to provide any fall protection, provided that the work is infrequent and temporary, and we implement and enforce a work rule prohibiting employees from going within 15 foot of the roof edge. Key term here is implement and enforce, right? You can't just say, you got a 15-foot rule. Yeah, okay, what's your fall protection? 15-foot rule? Well, what does that mean? It means 15 feet. Don't go within 15 feet. Well, the unit's within 6 feet of the roof edge. Well, yeah, just don't do that. Yeah, how, right? There's no solution here for me. Enforceable is all of our walk paths are designed to be at least 20 feet away from the roof edge. We have a warning line system at 15 feet away with temporary anchor points that you can move around the roof. If you have to go beyond that warning line, you have to tie off to an anchor point. Or any unit within 15 foot of the roof edge has guardrail around it. You're not allowed to go anywhere closer than 15 feet unless you're behind the guardrail. A lot of what we do is we do like U-shaped systems. We corral our units because, again, we want to engineer the traffic to always flow center, flow away. So we don't like to just put straight guardrail along the edge, because I'll go from that unit, walk along the edge, then go to the next one, and walk along the edge. So we like to U people in, engineer traffic to the middle, walk across the middle of the roof, then back out to the edge. But enforceability is the key here. And you have to have systems that back up your design and then your enforceability. Just a quick graphic. We're almost to the end. Talking about the closer that we get to the edge, the higher our risk rating. So therefore, those are the areas that we're going to prioritize protecting, right? If we take that same risk assessment that we talked about earlier, we replace likelihood of falling with distance from roof edge. It falls right along. The closer we get to the edge, the higher the likelihood of a fall occurring is, the higher the risk rating, the more critical, the higher the priority is for us to protect those areas. So when we come out and do an assessment, we're looking at access points, openings in the roof, and units starting from the outside in. And that's how we prioritize kind of tackling your roof. The way that we protect the roofs, again, we'll put a non-penetrating guardrail along the roof edge. We'll do corral systems in. If you need a demarcation line, we have a non-penetrating demarcation line. A paint on the roof is not a demarcation line. The Federal Register, OSHA's super clear. 8 months out of the year in Buffalo, it's snowing, so you don't even get to see the roof, so you won't see the line. They are very clear. It has to be a physical barrier, 39 inches tall, sag no less than 34 inches, visible from 20 feet. Last kind of concept I want to leave everybody with, and then we'll jump into questions, is the fall protection, the hierarchy of fall protection. It's an adapted version of the hierarchy of controls. And so what this says is there's a bunch of options that OSHA gives us, right? But what's the best option? And how do you measure best? So OSHA says we can do guardrails, I can do safety nets, I can do anchors, restraint, arrest, but what's the best option to do? So the way that we rank best is by the amount of risk that we're mitigating for the user and the owner, right? We want to reduce risk to as low of a level as we can. And we start on the top of the hierarchy and we work our way down. So This is the hierarchy. And then to the right, we have an example of an unprotected skylight that we're going to apply these principles to. What is the best option when solving any hazard? The best option is to eliminate the hazard completely, right? I said earlier, you can't fall through a skylight that doesn't exist. If I have a skylight, roof over the skylight, cover the hole, put decking in, can't fall through it. It's not a hole anymore, right? Now, sometimes that's not always practical, right? If I've got units near the roof edge, pour a concrete pad on the ground, repipe all your HVAC, have your HVAC set on the ground. Might be kind of expensive, might not be practical, but that's a way to eliminate the fall tied to HVAC maintenance from units that are on the roof. If we can't do that, we go one rung down. What's a collective or a barrier system that we can implement? We call it a collective system because it protects the collective group, right? If I have a guardrail or a skylight cover, a screen over a skylight, it doesn't matter if there's one person or 10 people on the roof. It's just going to sit there. It's going to do its job. I don't have to engage with it, set it and forget it, fall protection, right? It's just going to sit there and do its job for the next 20, 30 years. Now, we didn't eliminate the risk completely, right? Somebody could still jump over the guardrail, mess with it. So it's not as foolproof as elimination, but it is the next best solution from a risk management standpoint. If that's not practical, we'll go into work restraint or fall arrest. Now, when we make this jump, we jump a standard deviation up in risk that we're assuming because we're in the category of personal fall protection, meaning it only protects the people that are wearing the proper equipment and PPE. So if I have 10 people on a roof, only one's tied off, only one person's safe. Everybody else isn't. And how are they wearing the equipment matters. So is it, can you fit a hand, not a fist, under the strap? Is the lanyard fit for purpose according to the distance between the anchor and the edge? Are we trained properly to understand that it's a restraint system or not? Then if we can't do restraint, we go into arrest. We jump another standard deviation of risk up because we've introduced a fall. So now we have somebody who's fallen and we need to rescue them in under 15 minutes before suspension trauma sets in, right? And we end up with somebody hanging on the side of the building. They have blood pooling in their major arteries. They're probably unconscious from the whiplash of the fall. If we get them down in anything more than 15 minutes, we introduce high likelihoods of cardiac arrest, stroke, aneurysms, major health issues. So we need to have a rescue plan. We need to know that somebody actually fell, how to get them down safely, and then what the next steps are. So again, as we're talking about risk, what's the best option? We want to eliminate as much risk as possible. And that's really what we're here to do. As I said in the beginning, we are here to help you mitigate risk. We're here to educate you. We offer free rooftop safety audits. So we'll come out. I have a team of 25 experts in the field. We can be in any roof in North America in 2 days to check it out, provide complimentary site assessment. And if you want to get a jump on that, you can scan the QR code. We have a virtual assessment where you can answer questions about your roof and get a report back immediately so that you can help prioritize and wrap your head around the different hazards that you have to address. With that, I'll hand it back to Wendy, and we'll see if any questions came in that I can address here in the last 5 minutes.
I am confident, first of all, you can address the questions, and we do have them. But first, I have to offer an editorial comment that I'd like to have a word with the high schoolers who decided to use skylights as a trampoline. As a parent, my blood pressure was like through the roof. Crazy. Through the skylight. Okay, speaking of skylights, here's a question from Tony. Fiberglass skylights integrated into metal roofing panels are proven death traps, especially when they've been coated over during the life of the roof. Yes. Has OSHA made any moves towards prohibiting the flush-mounted skylights, forcing safety mesh to be installed? Anything else?
So OSHA considers those holes in the roof just like any other skylights. They are death traps. For anybody who doesn't understand, you have a metal roof, flat metal roof, and then you have a panel that looks like the rest of the roof, but it's a skylight made out of fiberglass. You have any snow on it, you can't see it. a lot of times they'll end up doing like a galvalume spray to extend the lifespan of the roof. You spray it, you basically paint the roof. They paint right over it, so now it looks exactly like everything else, and you're going to fall through it. Um, OSHA, the way they address it is they call it a hole in the roof that must be protected by the use of a cover. So we have screens designed for those specifically, those systems specifically. As a personal recommendation, before we do any roof walk, we have to ask, are there skylights on this roof? And if it's a metal roof, I want to go underneath it and look to see if there's any open panels to avoid. And if I'm going to walk a roof like that, I walk the peak only, because the skylights don't typically go all the way up to the peak. They're in the middle of the roof. Yep. So yes, they're death traps. They're terrible.
Well, let's talk about other people on the roof, in particular contractors. Randy wants to know that if we use contractors, do we have to protect them, or does their company have to protect them in these scenarios?
Good question. I always preface this question by saying I'm not a lawyer. I do not offer legal advice. Please consult a lawyer. So the onus of liability falls on the building owner. And there's tons of cases where the owner is liable. Okay. Now, when you go to a lawsuit, it's all about shared liability, right? So the lawyers are dividing up who has the most liability. So both are responsible, the employer and the building owner. But you are going to be seen as the primary responsible party for anybody on your roof. And if you say, be safe up there, and you have no measures for them to be safe, you have no anchor points, no guardrails or anything, they would say, well, we tried to be safe, but we didn't have any, reasonable means of tie-off. And so therefore you're liable. So the owner is the ultimately responsible party. Okay.
And keep your lawyer hat off or nearby, and maybe your OSHA hat also nearby. Talk about OSHA regulations differing from state to state. How do you speak to that? Yeah, I know you were talking about Cal versus US and all that stuff. What's the best way to kind of create that hierarchy for our audience?
Good question. So federal, if you have a local state code, the local state code can be more stringent than federal, but not less stringent than federal. Okay. So Cal OSHA is much more stringent than federal. Most states kind of just adopted the federal code as their own. Like Washington State has their own OSHA. I believe that Minnesota has their own OSHA, but there's only minimal nuances between the two. But then local building code can be even more stringent than state code. So you can get into like local, like IBC codes and things like that have even more stringent requirements that you have to be aware of. But for the most part, people adopt federal all the way down through.
Okay, that's helpful. And for everybody on the call, thanks for staying on. Dan, we probably have a few more questions. Do you think we've got time?
Yeah, I'm on as long as you're on, no problem.
All right, let's go. Paul wants to know about alternatives to ladders for accessing rooftops. Any recommendations?
Yeah, so, for low-level climbs, I always like to introduce stairs, stair towers. It's really hard to maintain 3 points of contact, especially if I need to get equipment up on the roof. I can carry a box of filters up a roof while walking upstairs. Typically on a ladder, you're going to climb, then you're going to throw a rope over the edge and try and lift your filters up while you're standing next to an exposed edge. So you have that secondary hazard related to it. A lot of times you'll see sometimes a ship's ladder, which is just a really steep staircase. You have to treat them like a ladder. So they have to be protected at the top with a self-closing gate, just like a ladder would be. Anything over 50 degrees is considered a ladder, not a stair. And then stair towers, we're seeing that kind of integrated quite a bit as well. Kind of the alternating treads going up and down. I think the bigger theme is really think critically about how many access points do you need on your roof and control them. So do I have a hatch? Do I have a staircase that I can use to get onto my roof? And then we have a random hatch. Go bolt that hatch shut and force everybody to use the stairs. Maybe they got to walk an extra 20 feet when they get up there, but it's better than having an unnecessary hazard on your roof. So eliminate the hazard by just bolting it shut and forcing people to use the safer access.
Okay. All right. Cameron asks about permanent roof anchorage versus temporary. As a government agency with less than optimal internal maintenance, may I assume installing permanent anchorage on our building roof is not optimum, meaning it's better for contract and maintenance contractors to implement their own temporary fall protection anchorage? What's your view of that?
Yes. And I mean, it's a complicated question without knowing the exact situation,
Yeah. Okay.
right? There's a difference between permanent and permanent non-penetrating. So you can have an anchor on your roof that you can move around the roof. So you can have it there that people can move, set up in their work area, tie off to, and go work on it, that we don't have to poke holes in your roof at all. It doesn't need the 5-year pull test requirement because it's a pre-engineered system. So you don't have to worry about as rigorous inspections on it. That's a better system than just saying, well, you got to get your temporary anchor point up there. Well, they're really heavy. They're a lot of metal. So it's hard sometimes to get temporary anchorage up onto a roof and set it up. So it would be better to have a non-penetrating permanent anchor waiting for them.
Okay. And I think you may have, as you answered that, partially answered or maybe fully answered Brent's question. You have buildings without anchor points. What can I do to provide those? What is available post-construction?
Yeah, I mean, non-penetrating permanent anchor points. You can also do non-penetrating permanent horizontal lifelines. So connect those together with a traveler, with a pass-through, so I can walk along the edge are really good options. But what you might find, when we actually look critically at what are we doing on this roof, you can guardrail, 2 areas and you covered 80% of the work being done in a given year. And then we just need one single anchor that I can move around. So it really depends on the situation and getting up on the roof itself and understanding it. But yes, you have non-penetrating but permanent options.
Wonderful. I think we have time for one more question. And if any other questions float in, or if I skipped past one, just everybody know that Dan's going to get all of these questions afterwards with information on ways to follow up with you. And obviously you've got some of those options here as well in some of our materials. So just to put my mind at ease one more time about these darn skylights, can you comment on managing those challenges around the rooftop solar structures? One more time, let's talk about how that all comes together. And maybe from there, also some parting thoughts, Dan, on next steps for our audience today, where they should kind of move forward in evaluating their own roof safety programs.
Yeah, great question. So we didn't even address solar. So I'm really glad that you brought it up. So again, talk about engineering your walk paths on your roof. How are you getting from point A to point B and back again? When we introduce solar onto our roof, we're trying to maximize the square footage of solar coverage. So what we end up doing is we fill the middle, we fill the safe part of the roof with panels, and we force all that traffic along the edge. So a roof before solar that would have been fine because I could get from point A to point B by cutting through the middle. Now I have to walk within 6 feet of the roof edge just to get from A to B. So all of my work, all of my travel is in that zone 1 critical area. So you end up requiring full perimeter guardrail on systems where I have solar to make sure that I'm safe, or a full perimeter horizontal lifeline that I'm tied off to while doing that travel. So thinking about safety integrated into your solar job is really important on the front end. Most of what we do is on the back end, on the retrofit side, but do it on the front end. And as far as next steps, I have 25 OSHA experts that want to be on your roof, that want to partner with you. The nuances in the details, right? All this makes sense. And then you're going to look at your facility and be like, oh, but we have this and this and this.
Right.
So there's nothing we haven't seen. So we want to come out. We want to look at your roofs, provide you with that assessment, that expertise, give you a report of what our findings are and how to fix it. You can take that report internally within your organization to get the approvals that you need to kind of take those next steps. So that we want to be your partner and help you with that.
Oh, that sounds great. And thank you for that. It's great resources. I'm going to encourage everybody to go into that related content module down there, pull everything out of there. It's pure gold. That is all we have time for today. I want to thank Dan for your terrific presentation. I want to thank Kee Safety for sponsoring this vital industry discussion. Nothing is more important than this level of safety. Download your slides, get the additional education resources from related content. Your CEO certificate is waiting for you in the Earn certification module. And to everybody on the call today, thank you. We appreciate you being here. We'll see you at the next Facilities Net webcast. And in the meantime, have a great afternoon. This concludes today's event.